Okay, three charges lie along the x-axis. So first let's try to draw the situation. We've got one positive charge at x is equal to 2 meters. So let's say x is equal to 0 all the way to 2 meters. This is where our first charge is. We're going to call this Q1. Then we've got a second charge, Q2, at the origin. Alright, we want to know where we have to put a negative charge so that the total force on it is 0. Well, let's look. We've got a positive charge here. Positive charge here. So if we put a negative charge somewhere in the middle, we're going to have a force this way from Q1. They want to pull each other together. And then Q2 is also going to pull it the other direction. Now if we look, if they were the same size charge, we can just put it right in the middle. And those two forces would balance. But we can't put in the middle. Q2 is larger than Q1. So we know we're going to have to put it somewhere over here. We got to put it a little bit closer to Q1 because Q1 isn't as large as Q2 is. So now we just got to figure out where do we put it so that our two forces are equal to one another. And I'll call this force 1 and force 2. Alright. So we know we've solved the problem and we can get F2 is equal to F1. This means the two forces are balanced and that negative charged object is not going to move. So let's use Coulomb's law to express F1 and F2. F2 So we're going to look at this force right here, which is with Q3 and Q2. Now, we're going to make up a distance here. If this is x is equal to 0, we can call this distance x. Once we found what x is, we've solved the problem. We know where to put that charge. All right. For F1, we've got Q1 and Q3. Now I'm not including the negatives here because when we take the absolute value it just becomes positive. So now we have to do a little bit of thinking. Where is, or how far is this distance right here? I'll use a different color. I can say this distance, let's try to put it in terms of x and something else that we know. So we know the total distance between the two is 2 meters. And we just called this distance x. So if I want to find what this distance is, how can I write that in terms of 2 meters and x? Well, I can say question mark is equal to, if I take my 2 meters and I subtract x, what's left over is my question mark. So in here I can write 2 minus x. Now, if I can set these two equal to each other and try to find and isolate x, I know my answer. I know exactly where to put this third charged object so that my two forces are equal. So let's go ahead and do that. Okay, so the next thing I want to do is set them equal to each other. So on the next slide, I've done this. Said F2 is equal to Q1, F2 is equal to F1. Subbed in my relationships for F2 and F1. So my next thing is just to solve. Now look what we can do. We have Q3 on both sides. So if I divide by Q3, it gets rid of that. I can also divide by K on both sides, and it gets rid of that. So now my relationship shows Q2 all over x squared is equal to Q1 2 minus x squared. Remember, what we're trying to solve for is x. Once we get x all by itself, that tells us the distance and where we should put this negatively charged object. So now we got to think, how are we going to isolate for x? There's a couple ways to do it. One is to expand, then cross multiply. Another way, a faster method, is to take the square root of both sides. Look what happens when you take the square root of both sides. I get the square root of Q1 all over x equal to the square root, sorry, that's supposed to be Q2. Q1 all over 2 minus x. This is a little bit easier to solve. So now what I can do is I can cross multiply. So I have 2 minus x. Don't forget your brackets. Now let's expand this. We want to get all the x's together on one side. So my plan is, if I expand this, I get 2 square root of Q2 minus x square root of Q2. Let's get all the x's on one side of the equation. And now what we can do is use the distributive property to get x all by itself. Divide by this term. What I do to one side, I have to do to the other. And I get x is equal to 2 square root of Q2 all over square root of Q1 plus square root of Q2. Now all that's left to do is sub in my values for Q1 and Q2, and I get my answer for x. So what I've done is I've subbed in my values for Q2 and Q1. So the rest is just type this in your calculator. When you type this in your calculator, you should find x is equal to 0.77. Now the units, the standard units, are going to be meters. That's what we use when we use Coulomb's law, meters. So let's just review what we did. We said for the total net force to be 0, our two forces have to be equal. If they're equal in opposite directions, then our net force is going to be 0. So we found expressions for each force. And we said what we're trying to find is this x. This x tells me where to put this third charged object. We set them equal to each other. We took the square root of both sides to isolate for x. We found that we should put it at 0.77 meters.